In this video, we'll discuss the core OOP concepts for low-level design. These are the core OOP concepts: class and object, encapsulation, abstraction, inheritance, polymorphism, association, aggregation, and composition. I'll also explain each one step by step with short example in Java. Stay tuned. Class and object. A class is a named group of properties and functions. So this is the class named car. A class is a named group of function. This is a function and these are the properties. So a class is a named group of properties and functions. A class is a template of an object. So a template is the blueprint of an object. Classes are data types. So here is where creation of class happens. See, this variable is of type car. So car is actually a class. A class is a data types. Classes are logical construct. Classes does not occupy space. They are just logical. So object. An object is an instance of class. So here is where creation of an object happens. See, this is an object. Car1 is a object. So object is an instance of class. Objects are physical reality occupying space in memory. So object actually occupies space in memory, not the class. Objects are stored in heap memory. Reference variable are stored in stack memory. So we have two types of memories. One is stack memory and the other one is heap memory. So objects are stored in heap memory. This actual object, when it is created, it is stored in heap memory. Whereas reference variable are stored in stack memory. The car1 reference variable is stored in the stack memory, and there is a pointer from reference variable to the actual object in the heap memory. So I think we are clear with class and object. Encapsulation. Encapsulation is wrapping up the implementation of data members and methods in a class. So this is a class and the data members here or here is a balance which is private. As it is private, it can't be accessed outside of the class. It is accessed via getters and setters. Here the setter is a deposit and the getter is get balance. The balance can be updated using the setter method deposit, and the balance can be obtained using the getter method get balance. So it keeps fields private, expose them via getters and setters. Abstraction. Hiding implementation details and showing only essential features, achieved using abstract class or interfaces. In this example, we'll achieve abstraction using abstract class. So here's an abstract class which has abstract method. This abstract method does not define what actually is present inside it. It just says what the feature is. So actually the information that abstract method contains is present in the child class. So this abstraction is achieved via method overriding or inheritance. This is the parent class vehicle and the child class bike. The child class extends the parent class, and the actual implementation of the start method is present in the child class. So hiding implementation details and showing only essential features. So it just shows only the feature and does not say the actual information containing in it. So it is achieved using abstract classes or interfaces. In this example, we achieved it using abstract class. So this is where abstraction happens. Vehicle object is created of child object. Uh, the start method is overridden by the child start method. This is abstraction. I know most of us has confusion between abstraction and encapsulation. Abstraction focuses on external stuff, whereas encapsulation focuses on internal working. Abstraction focuses only on the external stuff. So it says what is the feature but not the content in the feature. Whereas encapsulation focuses on internal working. Like in the above example, we have learnt uh, that the balance variable cannot be accessed outside of the class, but uh, it it is accessed via getters and setter method. This is what encapsulation. Whereas abstraction is the process of gaining information, and encapsulation is the process of containing information. The start method in the above example of the vehicle class doesn't have any information. It gains the information while creating an object, whereas encapsulation is the process of containing information. How well the information is contained for data hiding is called encapsulation. Inheritance. The child class inherits fields and methods from the parent class. It promotes reusability. Here's the parent class and this is the child class. The child class inherits the methods and the fields present in the parent class. Actually, the child class doesn't have eat method. The eat method can be inherited from the parent class, so it promotes reusability. If there's another child class, even that child class can use eat method without defining in it again, so it promotes reusability. Polymorphism. Poly means many, morphism means forms. So same method name but different behavior. So we have two types of polymorphisms. One is compile time achieved via overloading. The another one is runtime achieved by overriding. So overloading is same method name but different parameters or different data types, etc. So here's an example of overloading. uh, we have same method name add and the same parameters but different data types. The data types here is int, whereas the data type here is double. This is overloading. The overriding is child class changes parent method. So we have two classes here. One is animal class, which is parent class, and the child class uh, cat. Both have same method sound, but when you create an object of type parent, A is one of type parent, but the actual content or the object is of child of class child. So this child method overrides the parent method. So when you call a dot sound, it does not call the animal dot sound. It calls the child's dot sound. Association. Association is a relationship where two classes are connected but no ownership. That is, here the teacher class and the student class are connected. Here it's connected. When you print this, student is taught by teacher. It is connected, but both can live independently. Even though the student is not present, teacher can live independently, and also when teacher is not present, student can live independently. This is association. Aggregation. Aggregation is a special form of association, whole part relationship. One object has another, but both can live independently. Here we have two types of classes. One is department and the another one is university. university contains number of departments. We created two objects of department and added into the university. When university is destroyed, the even though university is destroyed, these department objects can live without university. So this is what aggregation state. If one object has another, but both can live independently. When university is destroyed, departments are not destroyed. Composition. Composition is a stronger form of aggregation. One part cannot exist without the whole. If the container is destroyed, contained objects are destroyed too. Here we have two types of classes. One is engine and the another one is car. The actual creation of object of type engine happens in a car. So when you create an object of car, automatically the object of an engine is created. So when you destroy the car, even the engine gets destroyed. So engine cannot exist without the car. So this is composition. If the container is destroyed, contained objects are destroyed. The container is car and the contained object is engine. When car is destroyed, automatically engine is getting destroyed. This is composition. I think we have learnt all the necessary core concepts of LLD.